too unhappy, but all right, one piece. The other one. Now I want to tap that, and I may actually have to press this in my elbow press here. She's going. Alright, we're going to go ahead and press this in the arbor press because I know it's moving. We'll just go and pop that out, and then we'll come back over here and take a close look at it. Alright, I think that one, or maybe this one here. Okay, that one there. Just that wall braze, or that braze build up there we got outside. I want it to be pretty level here. There we go. Alright, and we'll just slowly push that right on out that direction there, which is we're pressing it back out on the build-up side. So anything coming through the clean bore or untouched bore. Alright, that looks pretty cool. I like that. Okay, we pull up the piece there, and we went ahead and we blew it out with some air. And I'll give you a couple photographs of looking down in here real close with the camera. Alright, there's a little bit of lapping and right near the surface, not complete lapping like I worry about, but there's an area where there's a little hollow, a little void, and it didn't quite make contact all the way out to the graphite dam that we had, but it did keep everything in or out of the diameter of the bore, and we kept the bore nice and clean. This has still got to hold the load in the up direction here, so the tendency to pull or lift is still going to want to work on those areas that are crevices or the little folds at the surface there where it cooled down as one pass went over the next pass. And I like to seal those up there. What we're going to do now is, see, now we got it's cool and it's back to the state here. We want to see how much this has changed from our dimensions here already with that little bit of walling right there. And because I'm really wanting to go in there and completely seal those surfaces on the inside. Hold up. Hello. Alright, so let's go ahead and take some dimensions and find out how much this has actually changed. And we use these large pins here out of our thread pitch wires, and we used our dial calipers here, and this width was 1 inch 608, and that was measured about halfway in the wires here. One inch 612. Of course, it's been heated up, and then maybe some dirt and debris came out of there as well. And then 1 inch 610. 1 inch 610 is what we had. Let's just double check this here. Yeah, you know, it is down close to one at 610. Let's see what it is down here. It's a little bit larger. Okay, 608. I have 610 now on the average here. 611. 612. Alright, now the other dimension that we wanted to check was, there's 1 inch 28, 1 inch 30, 1 inch 30, 1 inch 27. Everything's maintained the same thing there. So it seems like we did get 1 inch 608, but we may add a piece of dirt or something in there because all of our other dimensions are right in there. All right, now we took a quick lap on this to show that we were flat, pretty flat on both sides. Now we can't do that on this because I got the buildup here, but we can do a light little rub on this side here to see if we have any, instead of taking a straight edge and trying to eyesight it with light, or these are some other ways to do it. We're just going to go ahead and quickly lay down a piece of paper. And this is nice and dark from the welding or the brazing going on here now. Alright, now we are touching here. We lift it up a little bit here and here. Put it down on the flat. A little tiny bit of rocking going on. We'll take it in on the granite table to see a little bit more. But this is not extreme. We knew it was going to pull a little bit. I mean, we're out here already a little bit, and we were somewhat hard here anyway, because the wear at both ends of your compound are always going to be a little bit more. And in fact, that's why you take a wire measurement in here, and that's why it was getting a little tighter in here than it was out here. You know, it was larger out here and here. The same thing at each end of your travel, or your fulcrum on this. And then of course the male slide that this slides on will have its wear in the middle and less out at each end. All right. I'm going to make the decision to go ahead and we're going to seal this area right in here, and then I'm going to go ahead and we're going to set it up in the Bridgeport, and we're going to go ahead and we're going to skim the weld down to where it's so close that we can lap the top of this, because we want to keep everything exactly the same, even his zero mark here with his line there for the rotation of degrees on the compound. I like to keep all of that intact. We're just coming in here to seal that very inner face right there. So it's going to be an ultimate little polish up here and here, and very little bit of machining work needed here. We came in and we cleaned off our granite surface here because we wanted to verify. On the steel table, the workbench out there, we got it to rock a little bit, and then I checked in a few different spots and it almost went away. And so some areas I could get it to rock, some areas I couldn't. So I said, well, let's bring it in here to the granite and let's get a feel to it before I actually do the brazing, added brazing. And I'm confident that now that I feel it on the granite and I have absolutely no rock, that my surface, and we did not create any warpage in this part so far, which makes me feel a lot better. And it is one thing that we didn't check this part at the very beginning, but I do know that we are rubbing here And now that we have a perfectly flat surface right here, let me grab a paper here. Yeah, I went all the way in the other room. All right. Of course, this is not glued down, but it is underneath here is perfectly flat. So now if we rub this and this thing is not rocking, we should probably see a little bit more broader pattern here, which we do. But no rock. So, you know, I'm real happy with our finding here. And now I'm going to go in and I'm going to do the brazing and finish sealing up these areas in here. Everything looks good and clean, and actually that carbon, actually there's no flux or anything down in there at the surface there, and that's probably why the flux didn't flow in there, because braze goes wherever the flux is for your initial pass. Getting close to the temperature we're looking for. I'm not supporting it with my clamps and everything else because I want to be able to reach in so close with the torch, and the weld is on the inside of the board, center line, between this outside surface and there, so I don't anticipate any warping in this part. It stayed so perfect the last time. And we're just going to be putting a little tiny bit just to seal that open surface there that we see in between the little passes. Okay, I know we're up to temperature now. Get my visor on. Get my gloves on. One little spot right here. Just fall in with some heat right here. There we go. Alright, now I know I sealed that all in. Now I'm going to rotate this around. I'm going to rotate it around real quick, and I'm going to need both hands and kind of move this camera here. Now you can see that torch really melted on this material right here, on the heat wrap here, because this is low temperature wrapping here, and I know that's going to be some hot. So, and I don't want to lose this part here, so I'm going to be flipping it over and doing the same position here. I like that. Up just a little higher. All right. Bring this back around. Okay. Before we lose the heat. Okay, I'm losing the battery on my small camera here, but we're going to do the same thing here as we did on the other side. So if I lose it, I lose it. I don't want to lose the heat. Okay, I'm happy with that. All right, we'll cover that up and we'll let it cool down. All right, this is a couple hours later, and we just lifted the top off there. And I want to point out this cloth material, A-cloth is what we call it, but it's not real A-cloth. Had asbestos in it and was in the shipyards, and it was used for heat blankets, wrapping, lagging, all kinds of different things. And of course, it's bad for your lungs and all of that. And it's been removed from any environment that we build or have in houses or boats or ships or steam plants and all kinds of things like that it was popular in. So this is a simulated material and similar to the fiberglass material also. Now when you get and you create so much heat, you will melt this stuff. It doesn't really flame up, but you get above, I think on this cloth here, you get above 1600 degrees or something like that, and it'll start to break down and melt. One of my other cloths is good for almost up to 2000 degrees before it actually starts breaking down. This stuff becomes like glass, okay, and very, very brittle. See, it's shattered like glass. Pieces all over the place. Just be careful about cutting yourself on the blanket. And, you know, after a while, your blankets do get kind of holy looking and stuff, but they're still good until you have no more material left. All right, so just kind of pointing that kind of thing out on the as far as handling that. I have been cut occasionally, and yeah, this is down to room temperature now, and man, got one little BB stuck there, but there we go. Maybe that's another one. Yep. Alright, now I'm happy because I joined that material in on the inside bore there. Alright, we're going to go ahead and we're going to go in and we're going to lay this down on the granite again. We're going to check for flatness there, and we'll do a real quick check right here just to go ahead and pacify ourselves on the width here. And I can't complain. Like we measured it before and we had a little bit different than what we had originally, but I think there was a piece of grit or something in there, because the measurement we had the second time was more equal. We were getting pretty close to 610, 612. We're getting that there now. You really want to see a lot of parallelism in this type of measurement here, and we're getting about 6.9 there, 612 out there. Like I said, in the middle, where you get less wear, you're going to wear more here and here on the part that slides, and on the stationary part, being the carriage, the center was going to have more wear. And that's how you get play in machines there. So there's like 605 right in the center. And of course I didn't really write that down when we started, but I knew that this would be tighter here, and I was just worried about end to end. Alright, let's go ahead and take this on into the shop, the machine end of our shop, and we'll double check this as far as its flatness, and then we're going to clamp this down on the mill table, and we're going to come and we're going to take the braze off the top surface here until we get it close enough to where we can lap this in on paper, and then come in with our Criterion boring head and skim out the bore so that we can get this thing ready and send it back to its owner. Alright, there's a good close-up on the bottom surface there, and you can see how the new heat or discoloring there from the last brazing, and you can get a good glimpse inside there to see that those areas have been brought out and they're smooth and 100% out to the surface now. We're coming back here before we clamp this thing down on our mill table, and there's no rock in here. And we take our piece of clean paper here, and we got our typical high spots right here, and this feathering out on each side here, the same as it was before. And it's very, it's lightly starting to scratch this area out here. Now we will go ahead and give this a little bit of a lap so we can make sure that we are 100% out there, because this is a surface that is supposed to be 100% flat. Although we know that probably the surface on the ways of the carriage itself are probably worn. Here you can start seeing we're picking up out here, out there at the ends. Just a couple more strokes, and I'm going to leave it as it is. He can lap and do a scraping or more sanding, or set it up and do some precision milling on it. You can actually clean up. You can redo your dovetail if you wanted to. All of those things are possible if you have a mill. This is not a real big compound or slide on a lathe. This distance is only about 7-8 inches here. Okay, I'm happy with that. We're going to clamp this thing down in the mill now. Go ahead and take all the high spots of the brass off of here, and then reach down in below this welded area here and go ahead and dial that bore in, and then come in and clean out the high spots here without, we're gonna machine that brass out without touching this. We're gonna try to get real close to it. If we have to feather it with a little paper, we will. Okay, this is a pretty simple part to set up on the mill to do the work we need to do. Now I just looked in it, I got a little bit of flux that I might have to chip out of there with a screwdriver, but that's no biggie. We pulled our vise off, we left our 2 T-nuts in here, and we have our 2 studs over here, and I think we're going to use one, and we went and got a larger stud and a toe clamp and a step block here, and I think because this hole right here that the feed nut actually sets up into is within the edge of this resting spot here. So we're going to go ahead and put the first bolt right through the hole there, and we're going to throw a washer on here. And I like using washers on surfaces like this so that the spin of the nut is spinning on top of the washer, and the washer sets there, and it kind of doesn't put a mark on the part itself, even though we're probably going to be lapping that. But we want to be, the idea of this whole thing is to skim this so close that it would be a quick lap on the top surface here without losing parallelism and the zero mark with the slash line, so that he can still use it to locate the rotation of the compound itself. Alright, now we'll screw this one in here, and this is how, and I'm not going to bother picking that up. I'm going to just get another one and I'll pick it up later, because that's bending over. I'm not doing that right now. Actually, there's a trash can, there's something else here. It's real tight. Alright, what I like to do is take the toe clamp, hold it parallel right here, scoot your clamp right, or your block right up to it, and then just go up one click, and then you're almost perfectly level there. And you know that you're a little bit of positive here. You know, when you tighten this down, you actually create a little bit of a draw. They are somewhat springy. If you're really a bull, you can bend them. You can mess up your stuff. Now, the closer the stud is to the part, the more hold with the less tension. You move it out a little ways, and it's a little less. Alright, this part is pretty flat, pretty secure. We don't need to really muscle that thing down, okay? But you want to make sure that it's tight enough to where it's not gonna move around on you. Alright, now we're gonna go ahead and we're gonna put a mill head in here. I think I'm gonna use my 4-flute head here. I like to use it versus a fly cutter. You know, I mean, actually, I'll get into it another time. I have tons of fly cutters. I even have one that's an R8. Alright. But they're not my favorite thing to use on a mill. What I found that works a lot better, and most of the time does exactly the thing that I want anyway, and that's to cut a broader surface. But I like it because it's more than just a single insert here. Okay. I'm kind of lining up the arc of this side here with the top of my braze buildup there, so I can kind of come and find out where the first initial touch off is. Now I'm locking my knee. This is an old mill, so there's a lot of play. So sometimes, you know, you bring on a little tension onto your locks and stuff like that, so that you're eliminating all the free movement in your knee, your cross on Y and Z, or excuse me, X and Y motions, and the quill is your Z, or your knee is, either one, vertical. All right. This is the highest of the low speed, about 325 on the standard belt-driven J head here, and I'm engaging my spindle feed here. All right. spindle feed so I can control my down very gently. Okay, I can see we're touching over here on this side here. Alright, I set 0 here. I know I safely have got 100,000s or better underneath there just by visual. But it is nice to stop and actually look at it. Okay, now we got a 0 set here, so let's pop this out. And one thing that's kind of nice is you can go ahead and bring this down, because I do have a readout on here. So 157. Now, because we don't know how, I mean, we have trammed in this head numerous times, but we always want to double check and make sure that we touch it off on this side here, but let's touch off this side on this side of the part here and see if we're doing the same thing. And there's 156. So we're within a thousandth anyway of being level. And we'll know more when we get into cutting the material, and we'll see if it back cuts, meaning if we're coming across the part and this side is cutting, and then as you pass that side is cutting, that's called a back cut. And that's because you're out of tram, or the table it's got so much sag and motion in it that it's actually dipping in, and it's in relationship to this 2-inch diameter right here, it's actually at a different height because of the way it's rocking. But I mean, that's extreme. Alright, we're back down to our 0. We lock it in, and we're going to go ahead and we're going to take let's just take 25 thousandths for right now. We're just feeding it by hand. We know that this was the high side over here. Now if we wanted to check for back cut, we just continue cutting until the cutter comes past that edge. And it does take just a slight bit. Now this thing will cut in any direction, so we can go ahead and we can feed down right now another 25. Okay, we're starting to cut on both sides here now. Alright, let me bring you in a little closer. Alright, there's another 25. That braze is looking pretty good. I only see a couple little tiny air bubbles in there, like one there, and one over there. But really nice and clean so far. And you know, it's sometimes actually when you're cutting brass, you get right there, and then the very last cut, you go, oh man, look at that spot. And that's really what, that was the prep, that's the first pass that you come over, and that's where you need to really make sure that that first pass is really joining the material good, and you got a good bond. I've had bores sometimes where you braze up the bore and it actually shrinks so much that when you bore it out, you bore out all your brass and you've actually brought in the original material, and you have tight tolerances with the original material. You could do that with welding and everything else, but it's more noticeable in brass because when you remove the brass, you know that you've already removed everything that you put in there. Sometimes when you wall up a bore, you don't really realize that you shrunk it. You brought in the outside material into the below the diameter that it was originally. Alright. We're going to take another 25. And we always kind of do a visual. You know, you can look at that gap there. Okay, we know that we have basically 25 to 28 or 29 thousandths to go. I'm gonna take 10 of that because I just verified that, you know, I can look and eyeball there, and then we're gonna grab the depth gauge and I'm gonna hold it across the flat, let the insert or the indicator of the instrument hang over the flat surface we're going to go down to, and I'm going to measure how much we have left, and then that's going to determine how I sneak up on that surface there and how much I actually leave over the top of it. Alright, so here's 10. Okay, so there should be about 11 left after this one. Okay, and also too, you can see how this has got cross hatches going this way, and then you can see cutter going this way here. That's just telling me that it is cutting a little heavier on the backside, but it is so close that I'm actually skimming both directions, and you'd be hard pressed to tram in a little closer than that. That's pretty good tramming in. Okay, we went ahead and I'm just going to pull this out a little farther because we're looking for a good surface here without any flux on it. It's pretty hard to find some. Maybe right in there. Let's take, bring this finger a little bit up. Alright. And we're just making sure we're past that point there. Alright, we're holding this nice and level right there with that finger, and we're reading about 16 thousandths there. I'm going to check, because I think we might be having a little bit of pressure there, and I want to get it real close in here. Yeah, I'm getting 16.5 over there. $17 over there. I'm checking it in a few different spots. Same thing. Okay, so we got about 17, but we're going to sneak up on it even. I don't want to hit any of this original material. I want to get that brass down. I'd like to get it down maybe a thou, half a thou above this surface if I can. It would be ideal. Minimum amount, go ahead and lap and bring in that surface when I'm done.